Assalamualaikum warahmatullahi wabarakatuh and good day. So in this video, we will learn how to find the point estimator using method of maximum likelihood. Okay, in your textbook, it will be in the page 476. So in previous video, you have learned first method to find the point estimator is method of moment. Okay, so this is the second method for you to find the point estimator. So if you look method of maximum likelihood, okay, suppose that the likelihood function depends on k parameter. Okay, the likelihood function depends on k parameters. So you have theta 1, theta 2 until theta k. Alright, so choose as estimate those values of the parameters that maximize the likelihood, this one. Okay, so this is the likelihood function. Okay, choose the values that maximize this likelihood function. Okay, so you can see here, we have random variable y1, y2 until yn. And then this is the parameter, theta 1, theta 2, theta k. Alright, so to emphasize the fact that the likelihood function is a function of the parameters, theta 1, theta 2 until theta k, sometimes we write the likelihood function as this one. Okay, so this is the likelihood function. Okay, and it is common to refer to maximum likelihood estimator as MLE. Okay, so we will illustrate this method with an example lah. Alright, so if you look at example 9.14, page 477. Alright, so a binomial experiment consisting of n trial resulted in observation y1, y2 until yn. So your yi is equal with 1 if the trial success, and yi equal to 0 if otherwise. So here you can see that we have binomial experiment. So when we have binomial experiment, how many outcome we have? 2 outcome. Okay, yes or no, true, false. So in this case, 1 success, 0 is otherwise. So otherwise it can be what? Failure, not complete, and so on. So the question asks you, find the MLE of P. So P is the parameter for binomial. Do you remember? Binomial, we have what? P is a success. Okay, a probability to be a success. Okay, the probability of success. So now to find the MLE of P. So the solution, okay, first you must find the likelihood function. Okay, so the likelihood of the observed sample is the probability of observing y1, y2, yn. Okay, you have n trial observation, and then y1, is it 1 or 0? Is it 1 or 0? Okay, so here will be likelihood function LP, which is equal with y1, y2 until yn, and then this is the parameter P. Okay, if in previous slide, this is the parameter. In this case, we only have one parameter, which is P. And then remember the density function of binomial. Okay, so the density function of binomial is given in exam or in appendix. So no need to remember. So you have P power y times 1 minus P n minus y. And then where here y is equal with summation yi I from 1 until n. Okay, in this case y ni is actually summation yi because we have y1, y2, yn. Okay, n trial. Okay, so now we wish to find the value of P that maximize LP. So that's the objective. Okay, so we just look if y equal to 0, what happened to LP? It's become 1 minus P power n. If an LP is maximized when P equal to 0. So analogously, if y equal to n, LP will become P power n. And LP is maximized when P equal to 1. Okay, so if y equal to 1, 2 until n minus 1, then the LP will become Py 1 minus P n minus 1. So the LP, okay, equal with Py 1 minus P n minus y is 0 when P equal to 0 and P equal to 1 and is continuous for value of P between 0 and 1. So for y equal to 1, 2 until n minus 1, okay, we can find the value of P that maximize LP, okay, by setting the derivative of this one and then equal to 0, then solve P. Alright, so that's, you can see the step. Okay, first you will have this one. Okay, you look the likelihood function. So here P, we have it. And then this one, we want to maximize P. We want to find the value of P that maximize LP. So this one just to show you the value could be or not. Okay, then you will do this one, derivative. And then you equal with 0. Then you will solve the P. Alright. So now look. So you will notice that the ln LP is a monotonically increasing function of LP. Okay, so both ln LP and LP are maximi for the same value of P. Okay, because LP is a product of a function of P and finding the derivative of product is tedious. Okay, so it is easier to find the value of P that maximize ln LP. So that's why instead of we have LP, we will have the ln LP first. Okay, so that's mean it will be first step, this one. This will be second step. And then you will have the third step here lah. It become this third, fourth and fifth. Okay, so you have LP. Now you find ln LP. You will get ln Py 1 minus P power n minus y. So this one, when you ln, okay, you will get y, you bring out, okay, you will have y ln P plus n minus 1 ln 1 minus P. Okay, so here if y equal to 1 to until n minus 1, the derivative of ln P with respect to P will be like this. Okay, so that's mean you differentiate this one. Okay, you differentiate this one, you get y 1 over P. Okay, you differentiate ln P, you get 1 over P. Okay, remember ln x, 1 over x, isn't it? So you have this one plus n minus 1. And then this one, when you differentiate, you get negative 1 over 1 minus P. Actually, you get ln 1 minus P. Ln x, 1 over x, which is 1 over 1 minus P. But then you differentiate negative P, you get negative 1. So that's why you get this one. Okay. So then for y from 1 until n minus 1, the value of P maximize, okay, or minimize is the solution of the equation. That means you need to equal with 0. Okay. So you have this one, you equal with 0. Right. Then you solve the P hit, what you get. All right. So this one you must solve first. Okay. This is they skip the step though. So basically you will have what? Okay, you will have y 1 minus P hit, okay, minus P hit n minus y. And then this one you will have P hit 1 minus P hit equal with 0. So this one, if you bring to the right, okay, it becomes 0 lah. So you will have only this equation. Alright, then this one, break the bracket, you get y minus y P hit minus P hit n plus P hit y. Minus minus, you get plus. So this one you can see negative y P hit y. So you can cancel out. Then you get y minus P hit n or equal with 0. So can you find your P hit? So based from here, you will have y equal to P hit n. So P hit will be equal y over n. So you get this one. Alright? Okay. So now you can easily verify that this solution occurs when ln LP and hence LP achieve a maximum. How is it? So you can see here. Okay, LP is maximized at P equal to 0 when y equal to 0. Okay, that's mean at P equal to y when y equal to n. So that's mean you can see here lah. Alright. At P equal y over n, okay, when y equal to 1, 2 until n, whatever, observe or value y, LP is maximized when P equal with y over n. Okay, you can see here. That's mean if y equal to, that's mean, you can see here lah, when P equal to 0, y will be equal to 0, isn't it? When P equal to 1, your y will be equal with n. How is it? From here lah. Okay, P hat equal to y over n, isn't it? So when P equal to 0, here is 0, y will be what? 0 lah, isn't it? Okay, because n times 0 is 0, so y equal to 0. So if P y over n, P equal to 1, so y equal to what? N goes here, n, y equal to n. Okay, so it's maximized when P equal with y over n. So the MLE, P hat, which is equal y over n, is the fraction of success in the total number of trial n. Hence, the MLE of P is actually intuitively estimator for P that we use throughout in chapter 8 later. Alright, so important here, you should know the step how to find the estimator using maximum likelihood method. Okay, so you can see here, first you should have the likelihood function LP, and then make sure you have the ln LP, make it ln. Okay, and then you find the derivative, the ln though, and then you equal with 0, and then you solve for P. And then you can see either you can minimize or maximize by substituting the value, okay, for the estimator here. So I will stop this video until here. Then I will go next video with this example. But for this video, I want you to understand the step how you find the point estimator using the maximum likelihood method. So this method is very important. Okay, you should know the step. So please try redo this example and then look. Do you understand or not? If you have any question, please let me know. Thank you, class.